Imagine a future where skyscrapers design themselves, where robots lay foundations, and where construction sites operate like intelligent ecosystems, learning, adapting, and building with flawless precision. That future isn't science fiction, it's happening right now. Artificial intelligence is revolutionizing the world of civil engineering, transforming how we design, plan, and build. From autonomous machines to predictive modeling, AI is creating a smarter, safer, and more sustainable built environment. You're watching Civil Engineering Edge, where we explore how technology and innovation are constructing tomorrow's world. Today, look, imagine a future where skyscrapers design themselves and bridges build with pinpoint precision. What if I told you that future isn't decades away, but being built right now? Discover how AI is completely revolutionizing the construction industry, making impossible feats a reality and constructing tomorrow's world. Today, intro, the silent revolution hook. The future is already building itself. Asterisk visual, wide aerial drone shot. A futuristic city skyline under construction. Autonomous cranes move in synchrony. Drones survey steel frames. Data holograms overlay building models in the sky. Soft, powerful music builds in the background. What if I told you the buildings of tomorrow aren't designed by architects alone, but by algorithms that think, learn, and evolve? Imagine a world where skyscrapers optimize their own shape for wind resistance, where bridges can sense their own stress levels and request maintenance before a single crack appears. This isn't a scene from science fiction, it's happening right now. Across the world, artificial intelligence has quietly entered construction sites, design studios, and project offices, transforming the way we imagine, plan, and build. From Tokyo's automated prefabrication plants to Dubai's 3D printed buildings, AI is not just assisting engineers, it's redefining engineering itself. The concept of construction has always relied on precision, coordination, and human expertise. But today, the complexity of modern infrastructure, smart cities, mega projects, and climate-resilient structures has exceeded what human teams can analyze alone. AI steps in as an intelligent collaborator capable of scanning millions of data points, identifying the most efficient material usage, and predicting construction outcomes with astonishing accuracy. Picture this. On a next-generation job site, robotic arms assemble steel components guided by AI vision systems. Drones continuously map progress, and a central algorithm monitors cost, safety, and schedule in real time. Every deviation, every inefficiency, every unsafe movement is flagged instantly. The site runs like a symphony, not by command, but by collaboration between human ingenuity and digital intelligence. This quiet yet powerful transformation marks the silent revolution in civil engineering. Unlike revolutions of the past that shouted through machines and smoke, this one hums through sensors, models, and code. It's the evolution of creation itself, where technology doesn't just serve construction, it becomes part of it. As we begin this exploration, remember, the skyline you'll see in the next decade isn't just human achievement. It is the outcome of minds, both biological and artificial, working together to build tomorrow's world. Be the current challenges in construction. Asterisk visual, cut to traditional construction sites, workers sweating under the sun, traffic-blocked areas, halted projects, and blueprints marked delayed. A soft tone underscores the struggle and scale of the problem. To appreciate how AI is reshaping construction, we must first understand the challenges that have haunted the industry for generations. The modern construction sector is one of the world's largest, contributing nearly 13% of global GDP. Yet, it is also one of the least digitized. Projects routinely suffer from cost overruns, schedule delays, and rework. Studies reveal that on average, large projects take 20% longer to complete and cost 80% more than planned. Why? because construction involves countless variables: weather changes, design alterations, material availability, and human coordination across hundreds of workers and suppliers. Even small errors early in planning can cascade into massive losses later. One miscalculated beam, one late delivery, or a misread design update can stall an entire project. These inefficiencies drain billions from global economies every year, and then there's the human cost. Construction remains one of the most hazardous industries, responsible for nearly 1 in 5 workplace fatalities worldwide. Despite technological tools and safety regulations, real-time awareness and predictive risk control have been limited until now. Adding to that are labor shortages and the demand for faster urbanization. Cities are growing, infrastructure is aging, and sustainability standards are rising. Yet, the traditional methods of project execution cannot keep pace with these pressures. At the same time, data fragmentation plagues the industry. Information scattered across drawings, spreadsheets, emails, and software platforms. Most of this valuable data remains untapped. It's here that artificial intelligence finds its greatest purpose. AI can synthesize massive datasets, learn from previous projects, and identify inefficiencies invisible to the human eye. It can transform guesswork into precision, risk into predictability, and delay into optimization. In short, the construction world is ripe for disruption. And AI is stepping in not as a futuristic luxury, but as a necessity, the key to solving the age-old problems of time, cost, and safety that have limited progress for decades. Thesis statement: AI, transforming construction forever. Visual montage: engineers using AR glasses, robots tying rebar, dashboards glowing with live analytics, 3D printed walls rising layer by layer. The score turns uplifting, symbolizing innovation and renewal. Artificial intelligence is not a minor upgrade to construction, it's a paradigm shift. Unlike past innovations that focused on stronger materials or faster machinery, AI changes the intelligence behind every decision. It's teaching the industry to think smarter, predict better, and build cleaner. In project management, AI now analyzes historical data and real-time conditions to forecast which activities risk falling behind schedule. Machine learning models detect subtle trends, weather disruptions, workforce performance, or material shortages, long before they cause trouble. Managers receive alerts, enabling proactive decisions that save both time and money. In safety management, AI-powered cameras and sensors continuously scan the site, identifying unsafe postures, missing helmets, or hazardous proximity to machinery. These systems have already reduced accident rates on experimental smart sites by over 30%. In material logistics, algorithms track deliveries, calculate demand fluctuations, and prevent waste by suggesting optimal ordering sequences. The environmental footprint shrinks, while sustainability goals strengthen. And when it comes to design, AI isn't just following rules, it's creating new ones. Through generative algorithms, engineers can input goals like maximize sunlight exposure or reduce steel weight, and the system produces countless optimized versions of a structure, each balancing performance and economy. This synergy marks the fourth industrial revolution in construction, where human creativity fuses with digital intelligence. The result is a smarter, safer, and more sustainable industry capable of meeting global infrastructure needs with precision never before imagined. AI doesn't replace civil engineers, it amplifies them. It frees professionals from repetitive calculations, allowing them to focus on creativity, ethics, and innovation. The engineer of tomorrow will not only build with concrete and steel, but also with data and algorithms. The revolution is underway, reshaping the very foundations of how humanity constructs its future, and this is only the beginning. In the next chapter, we dive deeper into how AI transforms the most crucial stage of all, design and planning, taking us far beyond traditional blueprints into the realm of intelligent creation. To AI in design and planning, beyond blueprints, a generative design, creating optimal structural solutions approximately equals 450 words * visual. A time lapse of a futuristic building design morphing rapidly, digital mesh transforming into optimized geometry, glowing data streams form towers and bridges as AI computes structural patterns. Narration? In traditional design, engineers sketch, simulate, and iterate, a process often limited by time and imagination. But what if a computer could explore every possible solution, guided by physics, efficiency, and sustainability? That's the magic of generative design, one of AI's most astonishing tools in modern construction. Generative design begins when engineers define a set of parameters, site dimensions, loads, materials, budget, or sustainability goals. Instead of producing one layout, the AI engine generates thousands of alternatives, each tested against structural performance, safety, and cost effectiveness. The system doesn't guess. It learns, refines, and evolves, discovering design solutions beyond human intuition. Imagine designing a high-rise tower in a wind-prone city. Traditionally, engineers might analyze 5 or 6 structural frames. With AI-driven generative design, the software explores thousands, each accounting for wind velocity, seismic loads, energy flow, and even sunlight exposure. Within minutes, the algorithm identifies the geometry that balances stability, comfort, and material economy. In practice, companies like Autodesk, Arup, and Airbus have used generative design to create incredible forms. Autodesk's Toronto office, for example, was designed through AI optimization. The program generated 10,000 potential layouts, balancing daylight, employee preference, and acoustic comfort, selecting the best configuration for human productivity. Similarly, in bridge design, AI algorithms mimic natural patterns like bone or coral growth to minimize weight while maintaining strength, a principle now used in 3D printed trusses and modular bridge decks. For civil engineers, this is revolutionary. The AI doesn't just draw, it thinks structurally. It identifies where loads can redistribute, where materials can be reduced, and how form can serve function with maximum efficiency. Engineers can now focus on judgment and innovation while AI handles the computational complexity. Generative design represents the future where data replaces guesswork and algorithms enhance creativity. Structures become more sustainable, lighter, and resilient. AI's ability to simulate and optimize thousands of iterations not only saves time, but also minimizes waste and cost. In essence, AI has become the co-designer of the modern world, crafting solutions that were once impossible to conceive. It's not the end of human creativity, it's the expansion of it. The blueprint is no longer static. It's alive, adaptive, and intelligent. Predictive modeling, forecasting time, cost, and risk, * visual. Dashboards filled with project analytics, timelines, and 3D models updating in real time. AI overlays highlight potential bottlenecks before they occur. Background, confident, analytical tone. In construction, uncertainty has always been the greatest enemy. Delays, cost overruns, material shortages, or unforeseen risks. But what if engineers could see the future of their projects before even laying the foundation? That's the power of AI-driven predictive modeling. Predictive modeling uses artificial intelligence and machine learning to analyze historical data, sensor inputs, and environmental conditions to forecast project outcomes with incredible accuracy. Instead of reacting to problems, project managers can now prevent them before they even arise. Every construction site generates enormous data, labor productivity, weather patterns, delivery schedules, equipment health, and material flow. AI sifts through all of it, recognizing patterns invisible to human planners. The system then predicts where potential risks may emerge, whether it's a scheduled delay due to rain, a cost spike caused by supply issues, or a safety hazard from equipment fatigue. For example, AI-based scheduling tools like Alice Technologies and Plan have revolutionized how engineers plan megaprojects. These systems learn from thousands of past projects, analyzing what caused delays or cost escalations. When applied to a new project, AI forecasts likely risks, suggests the most efficient sequence of activities, and even simulates multiple construction strategies to find the one that minimizes downtime and maximizes productivity. Consider a metro tunnel excavation project. The AI can analyze soil composition, machinery performance, and previous tunneling records to predict where collapse risks or slowdowns might occur. Managers can then reassign resources, adjust work hours, or strengthen supports before problems appear. The impact on budgeting is equally powerful. AI-driven cost models continuously update based on market trends, material prices, and labor rates, providing real-time financial foresight. This means project managers no longer rely solely on static estimates. They work with dynamic forecasts that evolve with the project. Predictive modeling also enhances safety. AI can evaluate site footage and worker movement to anticipate accident-prone areas, ensuring proactive safety measures. Ultimately, predictive modeling transforms uncertainty into precision. It gives engineers a digital sixth sense, an analytical intuition that sees risks ahead, controls costs, and ensures timely delivery. In the age of AI, construction management is no longer about reacting. It's about predicting, planning, and preventing. The result: safer projects, leaner budgets, and timelines that finally stay true to their promise. CBIM integration, supercharging collaboration and clash detection, approximately equal risk visual. Immersive digital environment. Architects, engineers, and contractors wearing AR headsets interact with a shared 3D model floating in midair. Lines glow as AI detects and resolves design conflicts automatically. Few innovations have transformed construction collaboration like building information modeling BIM. But when combined with artificial intelligence, BIM evolves from a visualization tool into an intelligent ecosystem, one that thinks, predicts, and coordinates every layer of a project in real time. Traditional BIM allows architects, engineers, and contractors to work on a shared 3D model. However, human coordination still leaves room for design clashes, a duct running through a beam, or misaligned columns between structural and mechanical drawings. With AI-powered BIM integration, these conflicts are detected automatically, even before construction begins. Here's how it works. AI algorithms continuously scan the BIM database, analyzing geometry, materials, and connections. When the system identifies a potential clash, say an HVAC line intersecting a reinforcement zone, it alerts the design team instantly. Not only that, AI can also suggest corrections, recommending the optimal routing path or dimension adjustments based on learned patterns from thousands of previous models. The power of AI BIM integration doesn't stop there. Real-time project data from drones, sensors, or IoT devices feeds back into the BIM model, creating what's known as a digital twin. This twin mirrors the physical site, tracking progress, material status, and performance metrics. Engineers and managers can virtually walk through the live model, spotting delays or design mismatches immediately. Companies like Trimble, Autodesk, and Bentley Systems are pioneering AI-assisted BIM platforms where machine learning predicts scheduling conflicts, material shortages, or structural stress concentrations. The system learns from every project, meaning each new build becomes smarter than the last. AI also enhances collaboration across disciplines. Structural, electrical, and mechanical teams no longer work in isolation. Instead, AI harmonizes inputs from all fields, ensuring consistency and accuracy throughout the life cycle, from concept to maintenance. Imagine viewing an entire smart city model where every bridge, tunnel, and high-rise updates in real time energy use, crowd flow, temperature, and structural health visible through an AI dashboard. That's not a dream. It's the direction in which construction technology is rapidly evolving. In essence, AI transforms BIM from a static 3D model into a living, learning infrastructure system. It doesn't just help us see buildings better, it helps us build them smarter, faster, and safer than ever before. Robotics and automation, the smart workforce, autonomous construction equipment, the smart workforce. In the modern era of construction, a new generation of workers has emerged, tireless, precise, and immune to fatigue. These are the autonomous construction machines, intelligent excavators, bulldozers, and dump trucks guided not by human hands, but by algorithms and sensors. They represent the dawn of a truly smart workforce. At the heart of this revolution lies artificial intelligence, integrating machine learning, LiDAR, GPS, and computer vision systems into heavy equipment. Imagine a massive excavator that can dig foundations all night long, guided by digital blueprints and real-time terrain mapping. AI enables these machines to read site conditions, detect underground utilities, and adjust excavation angles automatically. The result: flawless precision, minimal waste, and zero human risk. Companies like Built Robotics and Caterpillar are pioneering this frontier. Built Robotics has transformed standard excavators into fully autonomous digging systems capable of trenching hundreds of meters per day without human intervention. These machines operate using 360-degree cameras and laser sensors, communicating continuously with AI control systems to ensure accuracy. Meanwhile, autonomous bulldozers at large infrastructure sites perform grading and leveling tasks with sub-centimeter precision. Tasks that once took days now completed in hours. Beyond productivity, safety is the biggest gain. AI-driven vehicles can navigate hazardous or unstable terrains where human operators would be at risk. In mining zones, tunnels, or high-altitude construction sites, autonomy drastically reduces accidents and human exposure to danger. Furthermore, with predictive analytics, these machines can self-diagnose maintenance needs before breakdowns occur, eliminating costly downtime. The environmental impact is equally impressive. By optimizing movements, AI minimizes idle times and fuel consumption. Data-driven route planning ensures efficient logistics, reducing carbon footprints across large projects. We are witnessing a new paradigm: construction sites that operate 24/7, orchestrated by networks of intelligent machines. Engineers no longer manually control every motion. Instead, they design workflows, set parameters, and supervise fleets through digital dashboards. The synergy between human expertise and AI automation doesn't replace workers, it redefines their role. Operators evolve into system managers, focusing on strategy, data analysis, and site optimization rather than manual control. The result: faster projects, safer environments, and smarter decisions. Autonomous equipment marks the beginning of a construction ecosystem where precision and intelligence build the foundations of tomorrow's cities, efficiently, sustainably, and safely. 3D robotic bricklayers and welders, the precision builders. 450 words. Imagine a construction site where walls rise overnight, each brick placed with millimeter perfection. This isn't science fiction. It's the reality being shaped by robotic bricklayers and welders powered by artificial intelligence. These machines are transforming repetitive, labor-intensive processes into fully automated, high-precision operations. Traditional masonry and welding require years of craftsmanship. But now, AI-driven robots such as the SAM-100 semi-automated Mason and Hadrian X can lay bricks faster, safer, and with astonishing consistency. SAM-100, for example, works alongside human masons, applying mortar, positioning bricks, and aligning each one using laser-guided sensors. It can lay over 3,000 bricks per day, nearly 6 times faster than a human worker. Similarly, Hadrian X, developed by Australia's Fast Brick Robotics, uses a 30-meter robotic arm capable of constructing an entire house structure from a 3D digital model. The robot reads BIM building information modeling data, calculates each brick's exact position, and executes with minimal waste. No fatigue, no errors, just algorithmic precision. AI plays a critical role in this process. Computer vision systems guide robotic arms, while deep learning algorithms continuously optimize speed, angle, and force based on feedback from sensors. For welding tasks, AI-powered robots perform seam detection, path planning, and quality inspection, guaranteeing perfect joints every time. Systems like those by AB and Lincoln Electric are revolutionizing industrial-scale welding, especially in bridge fabrication and steel frameworks. Beyond productivity, robotics addresses one of the biggest challenges in the industry: labor shortages. Skilled welders and masons are becoming increasingly scarce. Robotic automation bridges this gap, ensuring projects progress without delay. These robots don't replace humans entirely. Instead, they allow skilled professionals to focus on design, supervision, and quality assurance. The consistency and accuracy offered by robotic systems lead to structural reliability and reduced rework. AI algorithms detect imperfections instantly, ensuring each weld or layer meets the highest standards. Moreover, automation cuts material waste, saving costs and promoting sustainability. The collaboration between humans and robots defines the construction sites of the future, where digital plans become physical structures with breathtaking accuracy. AI ensures that each repetitive motion contributes to an error-free, efficient build. In this new era, robots aren't just tools, they're teammates, silent, precise, and endlessly reliable, building the world brick by brick, weld by weld, into a smarter and stronger future. Drone-based progress monitoring, eyes in the sky, high above the bustling construction sites of the modern world. Fleets of AI-powered drones serve as vigilant overseers, scanning, mapping, and analyzing every inch of progress with unmatched accuracy. These airborne assistants have revolutionized the way civil engineers monitor, manage, and perfect construction projects. Gone are the days when engineers had to rely solely on manual inspections or incomplete progress reports. Today, drones equipped with high-resolution cameras, LiDAR scanners, and AI analytics provide real-time insights into site performance. A single drone flight can capture thousands of images, stitching them into detailed 3D models and topographic maps that reveal even the slightest deviation from design. AI is the brain behind this process. Using computer vision and machine learning, the system automatically detects inconsistencies between the planned model and the actual site condition. It identifies issues such as uneven grading, material shortages, safety hazards, or delays, long before they escalate into costly problems. This level of proactive quality control was once unimaginable. For instance, companies like DJI Enterprise and Drone Deploy are leading the charge with drone AI integrations capable of mapping vast construction zones in minutes. The data collected is then processed using AI algorithms that measure work progress, verify quantities, and even assess equipment utilization. Project managers can view these updates on digital dashboards, ensuring transparency and accountability across teams. In large-scale infrastructure projects, drones also enhance safety. They monitor hazardous zones, reducing the need for human entry into dangerous areas. AI-based object detection algorithms identify potential safety violations, such as missing helmets or exposed wiring, issuing automatic alerts in real time. Beyond monitoring, drones serve as crucial tools for documentation and stakeholder communication. High-resolution aerial footage and progress videos allow clients and investors to visually track development, improving confidence and collaboration. The efficiency gains are tremendous. What once required hours of manual surveying and data entry can now be done autonomously in minutes, with AI ensuring every pixel is analyzed. The result: faster decision-making, improved accuracy, and optimized project timelines. In the grand vision of AI-powered construction, drones represent the eyes in the sky, merging technology with oversight. They give engineers the power to see the invisible, to catch errors before they happen, to ensure perfection before completion. Through AI-driven drone monitoring, the construction industry is truly ascending, reaching new heights of efficiency, safety, and precision, quite literally building tomorrow's world from above. Optimizing project management and supply chains, AI-powered scheduling, dynamic project timelines that think for themselves. In the fast-paced world of construction, time is money, and delays can turn million-dollar dreams into financial nightmares. But what if project schedules could think for themselves? What if timelines could adapt automatically to weather changes, equipment breakdowns, or supply delays? Welcome to the era of AI-powered scheduling, where artificial intelligence transforms rigid project plans into living, dynamic systems. Traditionally, project scheduling relied on static Gantt charts and human intuition. Engineers manually tracked dependencies, adjusted timelines, and tried to anticipate conflicts, often after they had already occurred. Today, AI revolutionizes this process by using real-time data integration and predictive analytics to continuously optimize schedules. Every decision, from when to pour concrete to when to deliver steel beams, is driven by data, not guesswork. AI scheduling platforms like Alice Technologies, Oracle Aconex, and Procore AI simulate thousands of potential project scenarios in minutes. They analyze resource availability, labor efficiency, equipment status, and even weather forecasts to generate the best possible project path. If a supplier delay occurs or unexpected rain halts foundation work, the AI automatically recalculates the schedule, ensuring the rest of the workflow stays optimized without human panic or paperwork. This technology also enables resource allocation precision never before possible. AI identifies underutilized labor or idle equipment and reallocates them in real time. It highlights potential clashes in subcontractor activities and ensures that every worker, machine, and material operates in perfect harmony. In essence, the entire project becomes a self-regulating ecosystem. For large infrastructure developments like highways, metros, or smart cities, AI scheduling offers another major advantage: data transparency. Engineers and stakeholders can access cloud-based dashboards showing live updates, performance metrics, and progress forecasts. This real-time visibility reduces disputes, enhances coordination, and accelerates decision-making. The impact on productivity is profound. Projects complete faster, with fewer delays and dramatically lower overhead costs. The technology doesn't just track progress. It anticipates obstacles and proactively resolves them before they affect the critical path. In the AI-driven future, the project schedule isn't a static document pinned on a wall. It's a dynamic, thinking partner that learns, adapts, and evolves alongside the construction process. AI transforms project management from reactive firefighting into predictive orchestration, creating a world where construction flows with precision, not pressure. Predictive maintenance, preventing downtime before it happens. Every minute a machine stops working on a construction site costs money, time, and momentum. Traditionally, maintenance has been reactive of fixing equipment after failure, but AI has flipped the script. With predictive maintenance, machines now warn us before they break down, transforming downtime into foresight and efficiency. At its core, predictive maintenance uses AI algorithms and IoT Internet of Things sensors embedded within construction equipment, excavators, cranes, concrete mixers, and trucks. These sensors constantly collect data on engine temperature, vibration, oil pressure, hydraulic flow, and more. AI then analyzes this data to detect subtle patterns invisible to the human eye, the early signs of mechanical wear or potential failure. Instead of waiting for a machine to malfunction, AI systems like Caterpillar's Cat Connect and Komatsu's Smart Construction alert managers days or even weeks before a breakdown. For instance, if an excavator's hydraulic pump starts showing unusual vibration trends, the AI system predicts a future failure and schedules maintenance at the most convenient time, long before the issue becomes critical. This predictive insight leads to massive cost savings. Studies show that AI maintenance reduces equipment downtime by up to 50% and maintenance costs by nearly 30%. Moreover, it extends the lifespan of machinery by ensuring timely intervention and optimal performance. Beyond cost, safety is another crucial gain. Equipment failures on site can lead to catastrophic accidents. AI ensures that malfunction risks are minimized, protecting both human lives and investments. Through automated alerts, engineers can instantly know which machines require attention and which can continue operating safely. The technology also enables data-driven fleet management. Over time, AI learns from historical data, recognizing recurring issues, identifying weak components, and even suggesting better machine brands or models for future purchases. The result is a smarter, leaner, and more reliable fleet. Predictive maintenance represents a shift from reacting to problems toward preventing them entirely. It allows construction firms to maintain momentum, efficiency, and safety, the three pillars of modern project success. In this AI-enhanced world, construction sites don't wait for breakdowns. Instead, they move seamlessly forward, guided by intelligent systems that keep every bolt, motor, and circuit performing at its best, ensuring that progress never pauses. Smart logistics, the brain of the construction supply chain. Behind every successful construction project lies an intricate ballet of materials: steel, cement, glass, and countless components arriving exactly when and where they're needed. But managing this logistics puzzle has always been a daunting challenge. AI is now stepping in as the brain of the construction supply chain, ensuring every piece arrives with precision and purpose. Traditional supply chain management in construction often suffers from inefficiencies, late deliveries, overstocking, material shortages, or poor coordination between suppliers and sites. These issues lead to delays, cost overruns, and waste. AI solves these age-old problems by transforming logistics into a data-driven, intelligent network that predicts demand, optimizes transportation, and minimizes waste. AI logistics platforms such as Autodesk Construction Cloud and GEP Smart use real-time data and predictive analytics to synchronize every aspect of material movement. For instance, if a site's concrete usage rate exceeds the projected rate, AI automatically signals suppliers to increase the next shipment, ensuring continuity without over-ordering. Conversely, if weather delays work, the AI postpones deliveries to avoid storage clutter or spoilage. Machine learning algorithms track variables such as material costs, availability, transportation routes, and even geopolitical conditions. This enables predictive procurement, where AI foresees shortages or price spikes before they occur and suggests alternate suppliers or materials. In doing so, it ensures that construction projects remain resilient even during global supply chain disruptions. The integration of AI with GPS tracking, RFID tags, and IoT sensors brings real-time visibility to every truck and shipment. Site managers can monitor deliveries minute by minute, receiving instant alerts for delays or route deviations. This transparency eliminates guesswork and fosters accountability across vendors and logistics teams. Moreover, AI contributes to sustainability by optimizing transport routes to reduce fuel consumption and carbon emissions. By preventing over-ordering, it minimizes material waste, aligning modern construction practices with environmental goals. Perhaps most impressively, smart logistics systems connect seamlessly with AI-powered project management tools. The result is a unified ecosystem where design, scheduling, procurement, and delivery operate as one intelligent network. AI has turned what was once the most chaotic element of construction, logistics, into a symphony of precision. Every truck, shipment, and crane movement is choreographed in harmony with the project timeline. In tomorrow's construction world, logistics will no longer be a background process. It will be the intelligent heartbeat driving efficiency, sustainability, and success across every layer of the built environment. The future is now, challenges and opportunities, upskilling the workforce, the new age of construction talent. As artificial intelligence transforms the construction industry, one truth becomes increasingly clear: technology alone cannot build the future. It needs people, skilled, adaptive, and empowered people who can collaborate with machines rather than compete against them. This new era demands an upskilled workforce, one fluent not only in blueprints and concrete, but also in algorithms and data. For decades, construction has been one of the most labor-intensive industries in the world. But now, automation, robotics, and AI systems are taking over repetitive and hazardous tasks. Machines dig trenches, robots lay bricks, and AI schedules entire projects. So, where do humans fit in? The answer lies in reskilling and redefinition. The construction professional of tomorrow won't just be a site engineer or foreman. They lines be data interpreters, digital modelers, and automation supervisors. Engineers must understand how to work with AI systems, manage autonomous equipment, and analyze the data these technologies generate. In other words, the industry needs tech-savvy builders who can bridge the gap between traditional craftsmanship and digital intelligence. Educational institutions and industry leaders are already responding to this challenge. Universities now integrate courses on AI in civil engineering, machine learning for design optimization, and data-driven project management. Training programs led by companies like Autodesk, Trimble, and Caterpillar are equipping engineers with skills in BIM AI integration, drone analytics, and predictive modeling. But upskilling isn't just about learning new software, it's about a mindset shift. Workers must embrace continuous learning and adaptability. In this fast-evolving landscape, knowledge has a half-life. What you know today may be outdated tomorrow. The most valuable professionals will be those who can evolve as technology evolves. This transformation also brings inclusivity. AI allows younger generations, women, and differently abled individuals to participate in roles that were once physically demanding. It democratizes opportunity, making construction more diverse and technology-driven. Governments and private organizations must work hand in hand to provide accessible training and certifications so no one is left behind in this AI revolution. The future construction workforce won't just build structures, they'll build systems that think, adapt, and sustain. AI is not here to replace the builder. It is here to redefine what it means to be one. The future belongs to those who learn, unlearn, and rebuild their skills for a world where humans and machines construct greatness together. Ethical considerations, building with integrity in the age of AI. As AI reshapes construction into a data-driven, intelligent industry, we must pause to ask, what are the ethical costs of progress? The promise of smarter cities and autonomous sites comes with new responsibilities to protect privacy, ensure fairness, and uphold humanity in a world increasingly run by machines. At the core of AI's power is data, massive amounts of it. Every drone image, design simulation, and sensor reading contributes to smarter decisions. But with data comes the risk of privacy breaches and misuse. Construction sites equipped with surveillance drones and biometric monitoring raise questions about how data is stored, who controls it, and how securely it's protected. Ethical AI demands transparency and accountability, ensuring that information is used responsibly and with consent. Another pressing concern is algorithmic bias. AI systems learn from data, but if that data contains human bias, the algorithms may reproduce or even amplify it. For example, AI used for worker performance analytics could unintentionally favor certain demographics or skill profiles. Ensuring fairness requires diverse datasets, unbiased training, and continuous auditing of AI models. And then there's the issue of job displacement. As robots replace manual labor, fears of unemployment grow. However, the narrative isn't just about loss, it's about transformation. While some traditional roles fade, new opportunities emerge in AI operation, digital design, and system maintenance. The ethical challenge lies in creating pathways for transition, retraining workers, supporting communities, and ensuring technology uplifts rather than replaces. Governments, industries, and academic institutions must establish AI ethics frameworks, guidelines that ensure automation serves humanity, not the other way around. These frameworks should promote environmental sustainability, data transparency, and human welfare. In this AI-driven construction future, ethics becomes as important as engineering. Every algorithm, every machine decision must align with human values, safety, equality, and sustainability. The goal isn't just to build cities that function efficiently, but to build societies that thrive responsibly. Ultimately, AI in construction must not only build smarter structures, it must also build a smarter conscience. Because progress without ethics is merely automation, not advancement. Call to action. Building a smarter, sustainable future with AI as we stand at the crossroads of innovation and imagination. One question echoes across the skyline of progress. Are we ready to build the world of tomorrow with AI as our partner? Artificial intelligence has already begun rewriting the blueprint of construction, from design and planning to safety, logistics, and sustainability. It's creating an industry that is faster, safer, and greener than ever before. Yet the true measure of this revolution isn't in machines or algorithms. It's in our vision, our choices, and our willingness to adapt. Imagine a city where every building self-regulates its energy use, where bridges monitor their structural health in real time, and where construction sites operate autonomously with zero accidents. Imagine skyscrapers that adjust their form for wind loads, roads that repair themselves, and smart homes that communicate directly with infrastructure grids. This isn't the distant future. This is the world AI is already building. But to realize this potential, we must act. Engineers, architects, policymakers, and educators must unite in shaping an ethical, inclusive, and sustainable AI-powered construction industry. We must invest in education and innovation, create AI ethics guidelines, and promote global collaboration to share research and resources. The construction of tomorrow must not only be intelligent, but also responsible, designed for people, by people, with AI as the enabler. AI should be viewed not as a replacement for human creativity, but as an amplifier of it. It gives engineers the freedom to innovate beyond human limitation, to imagine forms and systems never before possible. Just as the Industrial Revolution mechanized labor, the AI revolution is intellectualizing construction, bringing imagination to life at digital speed. So, as we gaze upon the horizon of smart cities, autonomous cranes, and living architecture, we must ask ourselves, will we shape AI or will AI shape us? The future is not waiting. It's being built right now by humans and machines working hand in hand. Together, they are constructing not just cities, but the foundation of a smarter, more sustainable civilization. This is the promise of artificial intelligence in construction, a partnership between human ingenuity and machine intelligence, building tomorrow's world today. The future of construction is no longer drawn on blueprints, it's written in code. Artificial intelligence is not just changing how we build, it's redefining the very foundations of progress. Smarter cities, greener infrastructure, and intelligent systems. This is the world we're creating together. Yet, even in an age of machines, human vision remains the greatest force of all. With AI as our partner, we're engineering a new era of innovation and sustainability. This is Civil Engineering Edge, where the builders of today design the smarter world of tomorrow.